Good morning. So we're going to finish off our notes today with factoring polynomials. And today we're going to work on complex roots. So as we've seen with the quadratic formula, complex roots are those when you have a radical, and it could be a perfect square, it could not be a perfect square, but that you have a negative under the radical. So we're going to do just a couple of examples. It's very similar to what we've been working on the last few days. And so we're going to look at the function f of x equals x cubed minus x squared plus 9x minus 9. And I'm going to give you that one of the factors is x minus 1. Again, because I'm giving you one of the factors and we have a cubic, I need to find the remaining two factors. So I'm going to set up my little guide that I need to find two more factors. And I also need to make sure that I find all of my zeros. And so my zeros, again, I know one of them is going to be when x equals positive 1. And I need to find the other two. So I'm going to go off to the side and set up my synthetic division using that first zero. And again, notice that your polynomial is in descending order, and I don't have any gaps. So I'm going to use my coefficients 1, -1, 9, and -9, and just start my synthetic division. So bring the 1 up, and when I add vertically, I get 0. And that's okay. 1 times 0 is 0. Again, when I add vertically, now I get the 9 that I'm going to need to bring up to have my 0 as my remainder. So yesterday, when we talked about these, we have an x squared and we have a constant. And when we're missing that middle term right there, it's a lot easier to use the square root property. And so that's what I'm going to use to solve for my other two zeros. So I'm going to use the square root property. So I'm going to set my x squared plus 9 equal to 0. And now when I move my 9 over, I get a -9. It's okay that we have a negative on that side. When we take the square root, we're going to leave the negative under the radical. And again, remember with complex roots, that has a factor of -1 and a factor of 9, which is my perfect square. And every time we have a -1 under the radical, that's where we get our I. So my values for x, the square root of 9 is 3, and the square root of -1 is I. And I want to remember that because I have the radical here, I have 3i, but I also have the -3i. Because what I really have, and I don't really have space to write it, what I really should have written is plus or minus the square root of -9. Because I need to make sure that every time I take the square root that I always have the positive and the negative root shown. So these are my other two zeros. I'm going to put both of those on my list, 3i and -3i. But again, to find my zeros, I always have to go backwards. So again, if we remember when you have x equals 1, that when I move that 1 to the other side, x minus 1 is now on the same side, and that's how I create my factors. So I'm going to do the same thing for my two new zeros. And when I move 3i to the left, I get a factor of x minus 3i. And the same thing for this -3i. If I move that to the other side of the equal sign, I'm going to get an x plus 3i. And so those are my other two remaining factors. So we have completely factored this trinomial. We have three different factors and three different zeros. And so now my work is complete. So again, the only difference between these notes and these examples and previous examples is that now when I have a negative under the root, I will have an I listed as part of my zeros and part of my factors. So let's look at a couple more. Let's take a fifth degree. So x to the fifth minus 3x to the fourth plus 9x cubed minus 27x squared plus 20x minus 60. And for this, because I have a fifth degree and I don't have any common factors with any of these terms, I need to have some zeros here. I need to have at least one, if not more. So let's do this. I'm going to start us off with, I'm going to give us x minus 3 is a factor. Right. So given that x minus 3 is a factor, again, my directions, I want to completely factor f of x and find all zeros. So in previous examples, if I gave you a fifth degree or fourth degree, I would have to give you a lot more factors than just one. But I'm going to show you an example of something that's kind of a different case where I can give you just one factor and you can find the other four. So the process will be the same at the beginning. I'm first going to use that factor to find a remaining polynomial, just like I did up here. And then I'm going to see what can I possibly do next. So let's start with that. So again, my x minus 3, I have to use the positive 3 on the outside of synthetic division. And now my coefficients, 1, negative 3, 9, negative 27, 20, and negative 60. So I'm just going to make sure 1, 2, 3, 4, 5. I have 5 terms. Don't want to miss any. So I'm going to bring my 3 up, and again, minus 3 plus 3 is a 0. And that's okay. Sometimes that worries me, but right now it's fine. So 3 times 9 is 27. And then I'm going to bring this down and get a 0. And so we're going to be missing some terms in between here, but that's okay. Let's just see what we've got. So a fifth degree, so I'm going to start with the fifth degree, which means this is 1 power less, which means this is an x to the fourth, x cubed, x squared, x, and a constant. So what I'm left with is I'm left with a polynomial x to the fourth plus 9x squared plus 20. And if I am left with a fourth degree polynomial where the powers are half as much as I go down, so I have fourth, then squared, then none, they're all just the even powers, then I can actually factor this as I did with an area box. So I'm going to go through and I'm going to try to factor this one. I'm not going to set this equal to 0 and solve today. I'm actually going to use my older technique of area box. Let's see if I can factor this. And so with an area box, again, the first term, x to the fourth, is going to go in the top corner, and 20 is going to go in the bottom. And so I'm looking for factors of 20x to the fourth that add up to be 9x squared. And so because these powers are half as much of each other, instead of just one x, they each are going to get an x squared. Because x squared times x squared is x to the fourth. And then they would also be like terms to get 9x squared. Factors of 20, I can use either 1 and 10 or 5 and 4. And it looks like 5 and 4 are going to be the two factors that I need to add up to be 9x squared. Now when I factor outward, in this top row, they both have an x squared in common, which leaves an x squared up top. And I'll have a plus 4 and a plus 5. So right now, I end up with two factors, an x squared plus 5 and an x squared plus 4. Well, these are not linear factors. These are called quadratic factors because the power on the x on the inside is a second degree. Our job when we completely factor is to completely factor using linear terms. So what I need to do is I need to break up my f of x so that way I not only have an x minus 3 factor, but I need to separate these two quadratics each into their own separate factors. So every time I have a quadratic factor, it can always be broken down into two separate linear factors. And what I'm going to do is I'm going to use the square root property to continue to break these down. So off to the side, if I take x squared plus 5 and set this equal to 0, when I move 5 to the other side, it becomes a negative. And now I can take the square root of both sides. And again, that leaves me with the x on the left, and I'm going to get plus or minus what happens with the square root of negative 5. And because 5 has no perfect squares, there's not a whole lot I can do with the 5, but I can remove the negative 1 and make this plus or minus I root 5. And so one of my factors is going to be when I take the positive and bring it to the other side. And the other will be when I bring the negative to the other side. So again, if I take the positive I and put it on the same side as the x, it becomes the negative. And when I take the opposite, they change signs. So I get one of each. And that's one thing you want to recognize, is that when you have the plus or minus, it doesn't really matter at the moment how you think about which one is which. You know, if I start with the positive, it becomes a negative. If I start with the negative, it becomes the positive of the factors when I move over. So two of my factors are going to be x plus I root 5 and x minus I root 5. And now I need to do something similar then with the other two factors, the x squared plus 4. I need to set that equal to 0 as well. And so when I move the 4 to the other side, again, that one also becomes a negative. I'm going to take the square root. But again, 4 is a perfect square. So I'm going to get the plus or minus 2i. Because again, this is a factor of negative 1 and a factor of 4. So the perfect square gets removed and there's no longer a radical. And the negative I under the radical changes, or sorry, the negative 1 under the radical changes to I. So just like we did in the last two examples, if I were to move the positive 2i to the left, it becomes negative. If I move the negative 2i to the left, it becomes positive. And those are my other two factors. And so factor-wise, I've got all 5 of my factors listed now. And I did it with only having one rational factor. And the reason why was because when I did my first step of synthetic division, I ended up with a 4th degree that had even powers of the remaining degrees. And so the final piece I have to do is now list my zeros. So 3. And then over here, I already solved them. I've got a plus and minus I root 5, as well as a plus or minus 2i. So instead of listing them all out as 5 separate ones, we can always just do plus minus. As long as you remember, that means that you've got 2 in this group, 2 in this group, and 1 over here, which makes a total of 5.